Okay, we are now going to use the autograph program in order to find the zeros of a function and also to find the coordinates of turning points or points of inflection. And those, of course, are also where the first derivative is equal to 0. So we've got a function here which has already been graphed. The zeros are fairly obvious from the function equation, which appears on the graph, but we'll go through the motions of finding the zeros. So what I'm going to do is click on the function itself, right-click, and if you look down, I'm interested first and foremost to solve f of x equals 0. This will give me the zeros of the function, and I'm going to click on that. What the program is going to do now is calculate the answers for me. You can see them appearing down at the bottom of the screen. You've got two choices at this point. You can first of all view the results box, which will open on the right hand side of the screen and show you the details of the calculations that have just been made. Alternatively, what you can do is click on one of the points. So first of all, I want to take the highlight off the graph by clicking in a space not on the graph. I'm then going to go onto the point itself, click on it. I'm going to right click and I'm going to select text box, and it's going to give me the answers. Once again, this is the dynamic label. I can convert it to static text if I want to type them in myself. Potentially, for instance, if I want to modify the x value over there, minus 1.27 e to the minus 0.005 is effectively the numerical value of 0, and so you can do that. The advantage of the dynamic text is that if you modify the function, which in turn modifies the zeros, it will automatically update the text box. So I'm going to leave it as is for now, and that gives a summary of my results, which I'm just going to move a little bit out of the way for now. I'm then going to continue working on the graph in order to find the coordinates of the turning points, and in this particular case, remember that would also yield the points at which the first derivative is equal to 0. So once again, I'm going to click on the curve, I'm going to right click, and this time I'm going to select f dash x equal to 0, f dash x being the first derivative. We should now get our 2 points, which are clear from here and here. Once again, I'm clicking in a space not on the graph. I'm then going to click directly on one of the solutions to the f dash x equals 0, right click, and I will once again use a dynamic text box and click OK, and that is going to give me details of the x and y coordinates of the maximum and minimum in this case, or alternatively the x zeros of the first derivative function. And that is it.